It's really trippy. This whole semester, what's happened, like today, I did an example with my calc class. We were exploring a calculus idea, and they had to remember how to graph sine. And so many of them had forgotten. And I'm like, oh shit. Because, I mean, it happens so often. And I've said this to you guys before. The more you know the basic look of the graphs of these functions, the more you know about the functions. The more problems are going to be that much easier for you. Yes? So if you go into calculus knowing your basic graphs, your natural log, your sine, your absolute value, all this stuff, so many things become so much quicker and easier for you. Yes? Good, thank you. Next Tuesday we have no school. Yeah. Next Tuesday is Veterans Day. They have events on campus on the 10th, which I need to get a flyer from them about. And Tuesday is the holiday. So it's a weird middle of everything holiday. So, yeah. That's why if you look on the homework sheet, we originally were designed to finish lecturing over stuff on the 10th, and then the test was going to be the 17th because the 12th would be review day, and the 11th was a holiday. I don't think I put the 11th as a holiday on the sheet though, did I? No, I'm not that good. Okay, but the 11th is a holiday next Tuesday. So I'm assuming no questions on stuff. All right, let's do this. Clean sheet of paper. Get ready. Sorry. That's terrifying. This is not a quiz or anything, okay? Just get a nice clean sheet of paper. No calculators. I didn't even tell Maria about it. No calculators. It sounds yummy. I like making banana bread. I like making pumpkin bread. Pumpkin bread is yummy. I want you guys to do those. So this quiz on Wednesday, you're not going to be able to use a calculator on it. For the most part, I haven't really decided yet. For at least part of it. Do these.
Can we use our notes, or are we supposed to just...
No notes.
Okay.
But this is not a quiz, so I mean, feel free to make mistakes, but do as best you can. Monday night, after the time shifted and it's dark and we're all like barely here, like, do this, do trig. You do it. Figure out what those are. Tell me the value of those. Simplify those. Simplify. No. Do you use old bananas instead of eggs?
I don't know.
That's a possibility.
I didn't make it.
Yes. I'm glad you made it. We're doing these problems. See if you can speed run through those.
I'll do that in my sleep.
Okay, go to sleep. Alright, so it's okay if, obviously it's okay right now if you don't have these, or a way to get these memorized, but you're gonna definitely need it by Wednesday, right? That's what this quiz is on Wednesday. It's on these kind of values. It's on chapter 7. So that's a part of chapter 7. How many of you guys feel like you got 2 of these right? At least 2. Anybody? Kelvin's got his mouth feels pretty good. I mean, no, you got at least 1 of them right. Bless you. Okay, you got Damien because he's probably just answered one so far. Okay. Has anybody tried to develop a way to remember any of these? Or did any of the ways I tried to tell you make sense?
You know, it made sense to me, but I just haven't.
Had a chance to really put it in your head? I got you. Can somebody remind me, does sine like y or x? Y. Sine likes y. So what does that mean? That means the closer my angle is to the y-axis, the bigger the output for sine. The plus or minus consideration is another step. You just got to see what quadrant it's in, yes? You guys can know with me? So you can look at the reference angle. You can determine if that's closer to the x or y-axis. That tells you what value it has. And then you see what quadrant you're in. It tells you what sine it is, S-I-G-N. Okay. Sine of 45 degrees. What did you guys think that was?
I just do 1/2.
Okay, we got a 1/2. Anybody else have a feeling?
Square root 2. No.
Do it again.
Square root 2 over 2.
Square root of 2 over 2. We'll put some options then. Anything else? So if sine likes y and cosine likes x, where's 45 degrees? What's it closer to? It's in the middle. So that's kind of a trick question, right? It's in the middle. So it should be where cosine and sine agree. They have the same value, right? Do you guys remember like what's sine of 0?
0.
Because sine likes y. 0 degrees is all what axis? X-axis. So sine hates it here, yes? So it's like, I used to teach trig like a turtle. So sine don't like it here. It's very far away from home, so it's fully in its shell, right? And as it gets closer to home, it comes out of the shell a little bit. You with me? So here it's 0. 0 of it is outside. It's solely inside the shell. And then it grows as you go towards 90. So at 45 degrees, it's right in the middle of where it's growing. Cosine is coming back and it's becoming bigger and bigger as it gets closer to its home. How are we doing? Okay. So one of those 2 is the right answer. What do you guys think? It's root 2 over 2. Root 2 over 2. 45 degrees is where sine and cosine are the same. 1/2 is smaller than root 2 over 2, which is smaller than square root of 3 over 2. So root 2 over 2 is the option that's right in the middle. So let me try this. What are the extremes? Sine of 0, like we said, is 0. Sine of pi over 2 is 1. So those are the extremes. So the 3 in the middle are the 3 options for any angle that's not on an axis. So if I'm close to the x-axis, it's going to be 1/2. It's going to be the smaller one. If I'm close to the y-axis, it's going to be rad 3 over 2. It's the bigger one. If I'm right in the middle, it's rad 2 over 2. Right in the middle. Okay, maybe. Does that make sense what I just said? So you got the extremes. The extremes are the axes. And then the three in the middle are when I'm not on an axis. 30, 45, 60. 1/2, root 2 over 2, root 3 over 2. Yes? Okay. So with all that in mind, what's the cosine of 60 degrees?
1/2.
Yes. Yeah, I could have strung that along, but yeah. Why is cosine of 60 1/2? What is cosine like? What axis? It likes the x-axis. 60 degrees is closer to the y-axis, yes? So cosine's going to hate it there. So it's the smaller option. It's 1/2. Okay. How would you guys put tangent of 30 degrees together?
So what?
Okay, but I don't have any triangles to work with. I don't have any lengths of sides of a triangle to work
Yeah,
with.
sine of 30 over cosine of 30.
Yeah, so it's y over x?
Yeah.
Yeah. Okay, so it's sine over cosine.
Yeah.
You're good. Okay. I need you to stay with me now. I never memorized tangent. When I was a student, I did what Anas just said. And it's a fine way to do it. You put it in terms of sine and cosine, which you do have memorized.
Yeah.
So you don't have to do so much crap in your head, right? You can kind of work it out as you need it. Do y'all see, since tangent has sine on the top, since tangent has sine on the top, when sine is big, isn't tangent going to be big?
Yeah.
Let me ask you this general question. When sine's output is big, what's true about cosine? If sine's output is big, what am I close to? The y-axis. If I'm close to the y-axis, what's true about cosine?
Small.
Small. When sine gets big and cosine gets small, tangent gets really big. Yes? You guys see that? Okay. When sine is small, cosine is big, tangent gets really small. So, if you have sine memorized, I'm just trying to help you guys memorize this, okay? When you have sine memorized, here's what I do nowadays with tangent. Tangent is big when sine is big. Tangent is small when sine is small. So all I have to know is what could tangent be. Tangent could be, we've done some tangent stuff before. In this case, this would be 1/2 over rad 3 over 2, which is 1 over rad 3, which is rad 3 over 3. Oh my god, so I did it really quickly. Sine of 30 is 1/2. Cosine of 30 is rad 3 over 2. The over 2's cancel. You get here, you rationalize, you get there. Personally, I hate that shit. I don't want to do that every time. That's what young Jeff did. Young Jeff said, I'm not going to memorize this, blah. But here's the better way to do it. Tangent of 0 is 0. Because sine of 0 is 0. Yes? So tangent small when sine is small. So when sine is 0, tangent is 0. Tangent of 30 degrees, it grows a little bit. When sine is little, tangent's little. When sine and cosine are equal to each other, what's tangent? 1. So at 45 degrees, it's 1. When sine is big, tangent's big. That's just flip this. When these two flip relative size, yes? Okay, maybe. What happens at 90 degrees? What's cosine of pi over 2? What's cosine of 90 degrees? Undefined. Yeah, because cosine is 0.
Yes.
So not 0 divided by 0 is undefined, otherwise known as infinite. So on the graph of tangent, what's going to happen at pi over 2? Asymptote. Okay. I like it. And we're going to talk about the graph of tangent tonight. So when I do tangent, I say, okay, tangent of 60. Sine is big at 60. It's the bigger option. It's rad 3. You guys see what I mean? That is one way to do this. You could just try to straight up memorize these things. I'm never a big fan of that for me, but if it works for you, great. I need it to connect to an idea. And the idea it connects to is tangent and sine are connected. When sine's big, tangent's big. When sine's small, tangent's small. Okay, maybe. Okay. How do we do cosecant of 30 degrees? What's cosecant related to? How is it related to sine? Yeah, so this would be 1 over sine of 30. What's sine of 30 degrees? Yeah, because sine likes y, 30 is nowhere near y, it's going to be the smaller option. What's 1 divided by a half? 2. And then we got secant of 45 degrees. What's secant related to? Cosine. So this is going to be 1 over cosine of 45. This to me is kind of funny because, okay. So the 45 degree angles we normally consider sine is rad 2 over 2. That's after it's been rationalized. It starts off as 1 over rad 2. Do you see how this is a better thing to flip? So what would secant of 45 degrees? If cosine of 45 is 1 over rad 2, what's secant of 45 degrees? Rad 2. That's it. Okay. All right. So there's a lot of different ways to do these. You definitely have to have sine and cosine memorized. If you have sine and cosine memorized, you could build everything else you need if you wanted to. You wouldn't have to memorize anything else if you have sine and cosine memorized. What do I mean by that? Sine is 0, cosine 0, sine of 30, cosine 30, all those. Everything in the first angle, in the first quadrant, those 0, 30, 45, 60, 90, you're golden. Okay. And your calc teacher should expect you to know these. Okay. So here's what I want to do immediately. I'm working towards a little worksheet. But I gotta lay down some new stuff a little bit. Do you guys remember? Let's do this. Yeah, let's do this. That's fun. So on a quiz or a test, I would give you the steps, right? Like I would ask you for the amplitude. What's the amplitude? 1. Amplitude is what it's multiplied by, right? How do I get the phase shift? Yeah, how do you factor the inside? You gotta kind of force this a bit. What do I have to take out of the inside? No. That's what you could take out, I agree. But you have to force something. You have to take what out? Because I want to know what's happening to x. So how do I get x by itself? Why is x not by itself? Yeah, take a 4 out.
So would that be half?
When you take something out, you divide it out. What's 2 pi divided by 4? Pi over 2. So here, in case you have any trouble with that, when you take something out, you divide it out. So what you can actually do is you can write everything that was in there and just put it over what you just took out. Do you see that? You can always do this. And then that reduces to x plus pi over 2. What's the phase shift? Bless you. Which direction am I going to go? Yeah?
Yeah.
left by
Pi over two.
pi over 2.
Pi over 2 by left.
Yes, pi over 2 by left. And then I can talk about a period. How do I get my period?
Something over the coefficient. 2 pi over the coefficient.
2 pi over 4, I like it. And that, very often is called k, just whatever the number is. 2 pi divided by 4 is pi over 2. And then what's my step size? I'm going to try to do a problem where we don't do the begin and end and show you that you don't really need it, but you can use it if you want to. So what's the step size going to be? How do you get the step size? How many steps are there? How many major locations are there as we go through a cycle?
Is it period divided by?
There's 4 steps, right? Where it hits the, what was this, cosine? So it starts off at 1, so where it hits the x-axis, minimum, x-axis, maximum, right? There's always 4 steps, and I'll show you for tangent and cotangent when we get there. You guys with me? So no matter what, you're going to take whatever the new period is, and you're going to divide it by 4.
So pi over 8.
I think that was 10.
I think you're right. So if I take the new period,
Pi over 8.
divide it by 4,
Pi over 8.
yeah, pi over 8. Okay, kick ass. Now, I'm going to try to do this without, every single problem we've done so far, we did the beginning and the end. Let's try to do this without that. Where do we normally start? At what input do we normally start to draw our cycle?
0.
At 0. Cool. Now, where am I going to start now? Because how far did we shift by?
-1 or -pi over 2.
Beautiful. I went left pi over 2. So from your perspective, there it is.
Yeah.
I'm going to go back pi over 2. Yes? I'm going to start back there. Okay. Oh, good job, Jeff. So here's pi over 2, negative pi over 2. My step size is pi over 8, which kind of sucks for me. Especially considering this. I'm going to change this here in a minute because I didn't really plan ahead too long. I planned ahead. I didn't plan ahead, basically. Here, I'm going to do this instead. You guys can do what you need to. I'm going to, yes, I'm going to do this. It's like I didn't do that. Negative pi over 2. Now, what can I do with this? Because I have to step by this much, correct? And you're going to do this almost every time. I could just change this back. I can change this to be over 8. What would this be over 8? I want to make the bottom 8.
4.
Yes. So now I can step by pi over 8. So 1 would be 3 pi over 8.
Yeah.
2 pi over 8. Pi over 8. Yeah, I'm having a great time. 1, 2, 3, 4.
So it ends in 0.
And why does that match up? If that's my complete cycle, what's the period here? How far did I go from beginning to end? Yeah, 4 pi, I went 4 pi over 8, which is pi over 2, which is the period that we got, yes? So you can always check, where do I start, where do I end, how far apart is that? Is that the correct period I got earlier? If not, something went wrong. We're doing cosine? So where does cosine start? Yes, so it starts at the max, and then every step, the next step it goes to the midline, then it goes to the midline, max. Now when you go to draw this in, draw it with a dotted line. I'll show you why. So do a dotted line. Yeah, let's go a few more steps just because. Oh boy, this is bad. We'll be alright. Alright, there we go. That'll be fine. So I did like 1.5 cycles. Now, the reason I wanted to do this dotted is I want you on top of this graph, secant. So if this would have been my question, if I would have had to graph this, I would do everything we just did And at the end, so I would make this dotted because this is not the answer, this is cosine. Does anyone remember anything about secant? We talked about this a little before. What's on the bottom of secant? Secant is by definition 1 over cosine. So wherever cosine is 0, what's going to happen there? Womp womp. Undefined, which means what's going to happen visually.
It skips over.
Doesn't skip over it. I've got to tell it you can't go here. There's an asymptote there. Yeah. Let me really see if you get why. Do you all agree with me that the outputs are getting very small here? As I get closer to this input, aren't the outputs getting really small?
Yeah.
So 1 over those are getting really big. Let me try this again. So like right here, 1 over this is -1. Do you agree with me? 1 divided by -1 is -1. The minute I start moving, aren't my outputs smaller than -1, like closer to 0? So -0.9, -0.8. 1 divided by those are bigger than -1, or like more negative. Can somebody, 1 divided by 0.9, for example, is 1.1111. Yes? So when I get closer and closer to this, my outputs are stupid small. 1 divided by that is stupid big. My outputs are negative, so it's going to start going to stupid big negative. That is an asymptote. That's asymptotic. So right here, I've got to put a wall up. Right here, I got to put a wall up. Right here, I got to put a wall up. Right here, thank you. So 1 divided by -1 is -1. And then 1 divided by smaller than that is going to get bigger, and then it's going to go like that. So we did this before, where if you can graph cosine. To do secant, you just put the cups below, above. So here, 1 divided by 1 is 1. As these get smaller, 1 divided by them is bigger, and it's going to go to infinity there. And then down here, it's going to do the same kind of thing. But this would be a complete cycle for secant right there. It's just going to repeat these cups forever and ever and ever and ever. So this is what I said the last time we looked at this. I said if you can graph sine and cosine, you can automatically graph cosecant and secant, because it's just one more step to the end. Just throw some cups on it.
Is it good on the first part? Like what?
Duty. Oh yeah, I don't know why I skipped this poor dude. Over here, you mean?
Yeah.
Yeah, it'll go up there. There'll be another asymptote over there. Yes. I think the book sometimes wants 2 cycles. I don't see a reason for that. I normally just ask for 1 cycle. Okay. So I wanted to review that. We've talked about secant and cosecant, but like really quickly before. Now I wanted to focus on tangent and cotangent. Okay. And you guys are going to help me out. First thing I need help with from you guys is related to what we just did. Can you guys see that tangent's going to have some asymptotes? Where are they going to occur? So everybody with me? So we talked about asymptotes in the context of polynomial divided by polynomial, right? So the bottom you could factor and get x minus 1, x plus 2, and you can see x is equals 1 and x equals negative 2. You with me? That's what we did before. Rational functions. Are you guys with me? The general idea of vertical asymptotes are any damn time you have a function that could become undefined somewhere, you could have asymptotes, vertical asymptotes. And sure enough, like Brain just said, if cosine is 0, this thing is going to be undefined, right? So where's cosine 0? Oh, angle. Give me an angle. You're thinking about location. I want an angle. 9 degrees. So pi over 2. Now go backwards. So at pi over 2, it's cosine is 0. What's the negative angle where cosine is 0? No. Not 180. Do y'all agree with me? Cosine's going to be 0 on the y-axis. Of course it is, because it likes y. So of course it's going to hate the y-axis. It's going to be 0 there. No stars. Negative pi over 2. Which is also 3 pi over 2, but I want to go backwards. You'll see why. If I only have to graph one cycle, I kind of want it to be around the y-axis. I'm kind of used to being there. I could graph one cycle any damn place I want to, but we graph it around the middle. Does everybody really get what just happened? There's got to be a wall here. There's got to be a wall here. Yes? Whatever we graph between those walls will just infinitely repeat in both directions, because that's how trig functions work. They just sort of repeat their outputs forever. Do you all agree with me that tangents, where's tangents outputs positive? Let me ask you like this. Quadrant 1 and 3. Wherever sine and cosine have the same SIGN. Right? Because then they would reduce to positive. Yes? So doesn't it make sense that tangent's going to go through a full cycle in the first and second quadrant? It's going to hit all its positive and all its negative. And then it's going to repeat the positive, repeat the negative, repeat the positive. So tangents, period, which is why this makes sense. The walls are how far apart? How far apart are the walls? 1 pi. Yes? So the period for tangent and cotangent for the same reason is pi. What was it for sine and cosine and secant and cosecant? 2 pi. Too bad for them. Tangent gets the business done quick. So let's do a few things. What pi over 4? What's the tangent of pi over 4? No. What's the tangent of pi over 4? What pi over 4 is how many degrees? 45 degrees. Tangent is sine over cosine. At 45 degrees, what's true about sine and cosine? Yeah, because sine and cosine are the same at 45, yes? Why does that make sense? At 0, sine starts to grow, yes? At 90, if I go backwards, cosine starts to shrink. Does that make sense to say it that way? So of course, where do they kind of agree? If they're going the same rate, 45 degrees. So if tangents, the ratio of those two things, any pi over 4 related thing is going to be a tangent of 1 or negative 1, depending on which quadrant it's in. Are you guys at all with me? Okay. So pi over 4's output for tangent is 1. So what do you think the output is for negative pi over 4? That's insane. Why? What quadrant is negative pi over 4? The third. And the third quadrant? No, negative pi over 4 is not the third. Where's negative pi over 4? If you start at 0 and go back pi over 4, where are you? If you start at 0 and go back pi over 4, what quadrant am I in? 4. 4, okay, good. And what's true about sine and cosine? What are their SIGNs in the fourth quadrant? Positive. No. Cosine is positive. Sine is negative. So their signs are different. So therefore, tangent's output's got to be negative. What is tangent of 0 degrees? Or 0 radians? Doesn't matter. Yes. Because tangent goes like sine. Sine of 0 is 0. So at 0, tangent is 0. You with me? Yes, sir. Oh, I see. Sorry. I thought you had a question. You were just this good answer. This good. Huh?
On a unit circle, aren't all radians positive? Why are we using negative pi over 4?
No.
To represent 350 degrees.
See, here's another beautiful reason why I hate the unit circle. The unit circle makes it seem as if everything's contained between 0 and 2 pi and everything's positive. No, I can go backwards. I can have negative angles.
Yes.
I have infinite positive angles, infinite negative angles. I can turn this way as long as whatever, right? I can turn this way. So, I mean, all a negative angle, it's not a physical measurement, it's just the negative tells you what direction you're turning, that's it. So it's not like I'm moving negative something. It's just I'm going backwards.
And like radians are like physical measurement, and we can have like.
Oh,
negative half
I
meter.
see. Again, the negative just tells you what way you're going. So if the
On the
farmer
front.
starts at 0 radians and starts walking along, that's arc length.
Yeah.
Yeah. If he walks back, that's just it's fine for there to be a negative radian. If you want it to be arc length, you obviously can't put the negative in there. Are you with me? So that's just us realizing, no, it's got to be the positive for distance. But negative's fine in terms of direction he's going. Is that okay? All right, so does everybody understand analysis? And there's a beautiful point. If I want to figure out arc length, it's r times theta. If theta is negative, Jeff, you're telling me this man walked negative feet. That's some trippy shit. What is he growing in his farm? Don't want to partake too much of your own stuff. But do you understand? The negative has to be allowed because I can rotate the other direction. If I want an arc length, I'm just not going to represent my angle as negative. So real quick, what's a coterminal angle for negative pi over 4?
Wait, what?
Coterminal positive angle with negative pi over 4. What's coterminal mean?
7.
How'd you get that?
Because I just went in there.
You want the other one. Because what's 2 pi in terms of fourths? Do you understand the question on this?
8 over 6.
8 pi over 4, correct? So if we go back pi over 4 from 8 pi over 4, I go to 7 pi over 4. So if you wanted an arc length for this,
14.
right, you would have to use positive 7 pi over 4. But if you want an arc length for this, for like the negative pi, you would just use pi over 4. So we're the humans, we have to realize when we want distance, so I use the positive angle. Okay.
So the unit circle in negative is just the same thing in reverse.
How do you mean?
So this is a positive way.
Sure.
But if I'm going negative,
Yes.
it's the opposite way.
It's the negative. Yeah.
Yeah.
Okay.
Okay.
How we know so far? Now, do you guys see how this can't be a straight line? Number one, it's a freaking trig function. It's not going to be a straight line. It's going to be a curve. Number two, I got to run up against the wall and run up against the wall forever. So it can't be a straight line. It actually ends up looking cubish. If I filled in some more points, but I don't feel it. So this is going to be a really difficult cubish. It's really, really very subtly sloped in here because it's kind of a long way to go for it. You'll see if you graph a few of these. Plus, my scale being so bad doesn't really help. All right, so that's tangent. And to be honest, again, to make this point, it's going to repeat forever in both directions. Yes, it just repeats forever in both directions. As we normally just graph a representative cycle. Okay, I love you guys. What idea, well, let me see, that's a weird question. Do you see how amplitude don't mean shit to us? Because it freaking always goes forever up, forever down. Yes? Full. Yeah. But I use amplitude in a way. Let me see if you guys are cool with this. This was -1, this is 1. What would y equal to 3 tangent x look like?
Same thing.
Yes, except
Oh, that's when.
at pi over 4, where would it go? 3, because normally it goes to 1. So if I do 3 times it, it's going to go to 3. So there isn't truly an amplitude for tangent, but one of the main points we graph is directly affected by that multiplier. So I call it like quotation marks amplitude, right? So if I multiply by 3, it's going to go to 1 and to 3 and -3, right? At pi over 4, negative pi over 4. Okay, I like it. So there's no amplitude here, but I can use the multiplier to do something. Do you see how I'm still talking about 4 steps? 1, 2, 3, 4. So let me ask you a couple of quick questions. What would the period be for this? what would the new period be? Yeah, how do you always find it? It's the old period. Well, what's the period for tangent? How long does it normally take it to go through a cycle? Well, it goes from negative pi over 2 to positive pi over 2. So how long is that? 1 pi. So what's the new period for this? The old period divided by...
So it's 1/4 pi?
No. Divided by...
4.
No. 4 is the amplitude. Yes? Yes, divided by pi. So remember, how did we get the new period here? We divided the old period by the multiplier inside, yes? Alright, so what's the multiplier inside? Pi. So the new period would be 1. You guys see that? And what are the steps for tangent? Sort of like, okay, real quick. What are the steps for sine? Sine starts at 0, maximum, 0, minimum, 0. Yes? Those are the steps. What about tangent? Asymptote, -1, 0, 1, asymptote. Those are the steps for tangent. So I can move it around and do shit like we've done before. Alright, so here's what we're going to do. Okay. Because I am sensing you guys are needing a break from me talking. So we got an assortment of chips. This is how I'm going to put you guys in groups. 6, 9, 12. Ooh, I got 12. Okay. This will work beautifully. Everybody's here. Do I have everybody? Oh no, I'm missing Aubrey. So 2, 4, 6, 8, 10, 12. I guess I just didn't realize that. Okay.
Hey, give him some ribs.
Oh yeah. Here, help me out. Help make this random.
A minimum wage effort.
Huh? Yeah, that's how this is gonna work.
Yeah, we're in groups of chips.
Yeah.
Have whatever regular red chip.
I have chips, that's what I have.
Sure.
Just chips.
Okay. Let's find out. All right. I might have to swap somebody to the red team. We'll see. Who's got yellow chips?
Yeah, I think that's.
Yellow bag of chips. Yellow bag of chips. It could be yellow, purple, red, or something else.
Or something else.
I forgot. I have 2 reds. All my yellow chips, find a place to be. Okay, beautiful. Where are my purple chips? Purple chips. Sierra's purple. Alasia's purple. Is there another purple? There's gotta be another purple.
Pink. I don't know.
That's purple or blue?
Oh, let me see.
That's purple?
Yeah.
Let me see. There's purple, yeah.
Bro's colorblind over
All
here.
right. Hey now. Kendall and Sierra, yes? Why don't you guys go there with Alasia? I don't think she's gonna complain too much. Okay, blue. Where's my blue?
Yeah.
Yes, there is.
Okay, so there's 3 of you guys. This is interesting. So Mal, Kelvin,
No,
and
this is the best chip.
Fatima, do you guys want to
Best
go?
chip right now.
Oh, okay.
Last time?
All right.
I think so.
All right.
Wait.
If nobody wants to, I'm just
No,
gonna make.
no.
I'm just go. Somebody want to be
Pink.
red
Yeah.
chips? Anybody want to be team red?
I
volunteer to.
Okay. Kelvin, let this
Yeah.
drag. All right. So the rest of my blues get together, and then my reds. Did I get my reds? Holy shit! I still have 4. How in the world did that happen? Oh no, now okay. And us, Kelvin, and Damien. You guys. Maybe go over here with us. So, what I want you guys to do in your groups, I want you to work on this, and when you get it to a point where you think it's ready to graph, we're going to put them up here on the board.
Oof, God.
Yes.
Okay. I guess
I like
you're
how
the
you
teacher.
quickly. Okay. What am I even trying to? Did everybody noticed you had the same problem? Yes.
Oh, we did. Oh,
Yeah. Unfortunately, that kind of gives away the game for the next one. But when you put yours on the board, just make sure not to look at other people's. You never know. Somebody could have made a mistake or something. You never know. Did everybody get basically the same answer up here? You guys see?
Yeah.
Yeah. I love how there are many ways to make the scale and so forth. And then this group, of course, used every pen. I like that. Kick ass. All right, so we'll see if everybody else steps up. All right, so keep working on that tangent one.
Don't erase your work, guys. Be proud of your work. Don't, it's only okay to erase it when you're doing new humble beginnings for better work. Otherwise, be proud of what you do, all right? It's your creation, and don't let anyone tell you otherwise.
To have a, can you guys remember what it takes to have a inverse function? He's using it, sort of.
The horizontal line.
Horizontal line test, kick ass. And I'm sorry, yellow team. Oh my god.
No, my heart hurts.
That's an L.
Get out of here, yellow. Hit the alright.
Dang, bro's erasing our whole name.
Sound heavy.
Existence.
Okay.
F in chat.
So, if I have to pass the horizontal line test to have an inverse, yes?
Yes.
You all saw on your calculators that you have a inverse sign button, yes?
Yep.
But sine looks like this, yes?
Sure
So what's the problem with all that?
It doesn't pass the horizontal line.
Doesn't
test.
pass the horizontal line test. So, we didn't really focus on it a ton, but in order for a parabola to have an inverse, we had to like erase half of it. Do what's called restricting the domain. Good Lord, Brayden. What's going on? You're like, I'm gonna try to be as loud as I can. Right next to the
So
camera.
you should sit in the front.
Wow. All right.
It's not my fault the chair's loud.
Okay.
Yeah, for sure. Okay.
We're gonna do something very similar. Whenever we have to restrict the domain, that's going to lead to some problems later. But you all agree, ain't no way the entire sine function is gonna work for an inverse. It don't pass the horizontal line test. So somebody remind me, what is this value here? What is this? What angle gives me? This is 0, by the way. So what angle is this?
30.
No?
90.
90, so pi over 2. Negative pi over 2. So if I chop it here and here, so I end up with this graph.
Get past the vertical line, so.
Yeah, no. Okay, so then, there. So that's going to pass the horizontal line test. It's going to have an inverse. The problem is, okay, remember how inverses work. What do inverses do? They take all the x's and the y's and they flip them, which means domain and range flips. What is a sine? What do you feed? This is going to be a weird way to say this, and I don't care. What do you feed a sine? What do you put into a sine? What kind of thing do we put in there?
Y over.
No, what? No. What do I take the sine of? What kind of thing?
A degree.
An angle, right? An angle. You
Oh,
with me?
I
So we
mean,
take the sine of an angle, and we get a number out. Is that cool? Inverse sine would take the number, because again, like you guys told me, it switches the x and y, it switches the inputs and the outputs. It would take the number and figure out what angle it came from. But notice what happens. What is the biggest angle that the inverse sine could give me? This is the sine. We had to chop its domain. What's the sine's domain in order for the inverse to exist? What's this guy's domain? Negative pi over 2 to pi over 2. Yes? And what's the range?
1 to negative 1 to 1.
Negative 1 to 1. So for the inverse sine, what's the domain? You can do it. Don't think too much.
Negative 1.
Negative 1 to 1, because inverse stuff switches x and y's. Inverse stuff switches domain and range. What's the range going to be?
Negative pi over 2, pi over 2.
So if my actual angle answer is supposed to be pi, could the inverse sine ever give it to me? What's the biggest output the inverse sine could give me?
Pi over 2.
Pi over 2. So the answer is the inverse sign gives me, because in order for it to exist, in order for the inverse sign to exist, we had to chop the domain of sine, which later meant we kind of took away some of this guy's power, right? It can only give me so many angles as an output because it needed to chop the number of angles it has as input. Okay, maybe. So for example, real quick, if I said, what's the inverse sine of 1/2? Now how do you think about that question? You think about it backwards. What sign has an output? What angle has the sine of it is 1/2? What angle do I take the sine of to get 1/2? Sine of what is 1/2?
30.
Do it again.
30 degrees.
30 degrees. 5 or 6, yes? So this output would be 5 or 6. What about the inverse sine of -1/2? Do it again. -π/6, because I'm only allowed to have outputs between -π/2 and π/2. Are you with me? Okay. There will be situations where the answer is actually supposed to be 7π/6. Do you all agree that 7π/6 has a negative angle, a negative output for sine? Because y is negative?
Yeah.
I really want you all agree that -π/6 has a negative output. So does 7π/6, yes? If that was supposed to be the angle I get, will inverse sine ever be able to give it to me? 7π/6, can it get there? No, which is not its fault, right? So we have to know when the answer we get is actually a reference angle. It's like inverse sine is telling me as much as it can. It's like, dude, just go down and we just went down π/6, hey, we'd be there. But we have to recognize, so you'll see, we'll get there to some of these problems where you have to not just stop at the answer you get, but go further, because it's not quite the right answer for the situation. Okay, maybe. We'll get there. Does everybody understand that we're going to have a trade-off of the information we can get just to have these things exist? Same thing's going to happen for cosine, same thing's going to happen for the other ones. All right, so we'll talk more about these. These are inverse trig functions, yay. We have to know how they work because the only way I can solve equations is if I know how to undo a function. And that's what inverse functions are about. So you're like, if you didn't love trig already, let's talk about anti-trig. Let's talk about inverse trig. So we'll do that tomorrow. All right. So come ready with all the questions so we can get ready for the quiz on Wednesday. All right. Thank you for playing along, guys, with my chips exercise.
Outro time.
Oh, yeah. Outro. Cool.
Outro time.
This is Damien. Up and coming. Young man.
All right. So quick recap of today. Perhaps the trig we learned was the friends we made along the way. Yeah. So thank you for listening, viewing, and subscribing. Make sure you turn on post notifications, and if you made it to this point in the video, make sure you comment red chips on top. Make sure you comment that, so we know we got engagement, because it's important. And yeah, thank you guys for watching. Make sure you turn on post notifications for every video. Peace. One of those.
All right. Thanks, Damien.